Hey guys, welcome back to the shop. So we're going to begin working on the second fixture plate now. We just finished the first one. This is going to be a 2-machine operation. The first one we're going to do is go to the American Pacemaker Lathe, and we're going to do all of our facing work there on this fixture. And then we'll come back to the Flex CNC. We're going to finish out our hole patterns here, which after that we can then bolt it down and actually begin the machine work on the aluminum work pieces. So let me give you a little heads up of what we're going to be doing here. I've already got our magnetic vices set up so that we can hold the fixture right here whenever I get through with the lathe work, and we can put our hole pattern in there. And the way I've got these staggered out is that it's not going to hit any of the magnets whenever it drills the 4 mounting holes. And then we simply have some drilled and tapped holes here in the center that's going to hold the aluminum work pieces down. So once it's through with the drill in here, then we'll actually pick it up. We're going to move our magnets out of the way, and it'll get bolted directly down to the bed rails there. So here's the fixture that we just finished, and here's our sample piece, and you can see how it fits in there and what it looks like. And what I had wanted to do once I started figuring out this job is to have the 2 work locations just like this. First one's going to be just like you see, where it's going to be sitting down into the machined recess that we machined in there and held down with the 4 clamps. We can get in here and machine this bore just like it is there. Got a little clearance here for our cutter. And then once we're through on this side, let's see if I can pick this up out of here. We can then take it out of that fixture there, and we can set it right over here on this fixture. And it's going to have a registered fit that the center bore will slide down and fit and keep it centered up. We're going to have some tapped holes there so that we can use our clamping ring, which is actually still over on the big table. So there's a ring that slips down in here, and we'll have 6 bolts to hold it down. And then you see I've got it just enough where we're pretty much supporting the entire aluminum disc here, but we have enough clearance that, you know, we can come over here with our cutter. We're not going to be hitting the fixture itself. So we'll get that clamp down, and my plan is to mill this. I've got a couple of helical cutters on order, and I'm hoping that we can get a good finish on this. Remember that this is something that isn't mechanically functionable in any way. It doesn't go on any kind of machine or piece of equipment. This is simply a trim ring, a beauty ring for a light fixture, something that's going to sit down on the ground and just look nice. So we want to have the best finish we can get. And my backup plan is if I can't get the mill to give me a good looking finish, then we will backtrack and probably take this to the Pacemaker Lathe and just use a lathe to turn this. But I am definitely trying to get this accomplished in the CNC mill. All right, so we're going to go ahead and get started on it. We'll take our fixture there over to the Pacemaker and start our face cuts. So I've already got the 4-jaw chuck set for the OD of my plate here, which is burned out at 20 inches. Let's see if it fits down in there. Tried to get it pretty close to 20 inches. All right, I need to move it just a bit. There's a little raised area there where the cut started and stopped. So let's go pick it back up just a touch. Do it like that. All right, that's got it held. All right, we will go around this and indicate it. First thing I wanted to do is just go ahead and bump it, try to get the plate touching the face of all 4 jaws. That one looks good. That one looks good too. I can just barely see any. It's probably going to be good enough. We're just wanting to make sure it's average flat across that back side. What we're going to do here is we're going to drill a hole in that. I'm going to drill a hole. That's going to be my centering hole once we go back to the mill that I can indicate on. That'll be our XY0 on the fixture. So once we drill a hole, we'll just go ahead and face it off one side, just put a little chamfer there, and then we're going to flip it around, bump it against the jaws, face the other side with our registered fit on there. All right, so we're going to go ahead and get started indicating this, and this is a perfect opportunity to highlight a new indicator tip that I recently received from a friend of mine named Ernie Hayes. He came to visit me and gifted me an absolute amazing clock that he made, and he collaborated with Starrett on some of the contact tips that he used in the clock. And him and his wife came by and visited and gave the clock to us. What an amazing gift that he made for me. I can't thank Ernie enough for that. But while he was here, he actually brought me this guy too. This is a roller tip made for these style AGD style indicators right here. Okay, it's got like a ball bearing on the end of it, so it'll just roll across those rough edges like that. Ernie had sent me one of these in the past in the mail, and it got lost. It got the envelope got tore up and it got lost, and he decided to pick up another one and give it to me. So thank you, Ernie, for that. We're going to put it to use here. So I've got it on our handy little Starrett indicator tip set here. If you guys don't have one of these, I highly recommend it. It is the Starrett number 25R indicator tip set. Got all of your different tips. And if I didn't have this new roller tip from Ernie, this would be a good one too. This is a spring-loaded tip. That works good for uneven surfaces there as well. But anyway, we're going to use Ernie's roller tip that he gave me. Take this one off. Put it on our ring here. And that just stays in the Gerstner box all the time. And let's screw this guy on here. So there's a lock nut on there too, so that you can get this, aligned the way you want to. That looks pretty good, just like that. Out far enough that we're just not going to hit the chuck jaws there. And then now you got a tip that simply rolls across all those rough edges instead of the tip of it, engaging in each little edge in that flame cut. That's going to work out pretty good. All right, so let's go ahead and get her indicated. We'll get you closer so you can see what's happening here. All right, let's see where our high is. This is a little tricky because it jumps just because of those edges, so you have to keep up with both needles there to see where you're at. 70, and it's pretty close, so that side's low. So if we come over here, let's just call that 50, and this side's on 70, so it's about 20 thou difference. Let's just call it 55. That's about 55, 60. We'll just go ahead and snug that one. I might have went a few thou too far, but that's not a big deal. That one's pretty good. Let's go to these two here. So where are we at there? That's about 30. Keep track of where the needle goes. All right, that's low right there. So we need to back that one out, tighten up the high. 20 and 10. Just a little bit. So we weren't that far off. Pretty close right there. I know I keep going past it, but I'm trying to avoid those low and high spots there and stay mainly on the better radius. I'm going to call that one 15 thou. That's a pretty good spot right about there. And then I'm not even looking. We're just going to come around here to this other jaw and just kind of roll it. And you can see pretty close. 5/10 thousandths off probably. That's going to be good enough. Not a big deal. We're not even machining this OD. It's going to stay flame cut just like it is there. That one's around 55, 60-ish. Let's come to this side. That's around 55. So I think we're good. Really no reason to keep messing with it and tweaking it, because we don't need it to be turned. What we're going to do is drill that hole in there, and once we flip this thing around, we're just going to indicate that hole in the center. So our roller tip worked beautifully, Ernie. Thank you very much. One of the things I was concerned about with this disc is that we're reaching the absolute maximum capacity for swing on the pacemaker here, and that's with the jaws flipped around, chucking the outside of the disc. But if you look right here, this is places where the jaws have probably hit before, and on other lathes that I have used, the other American Pacemaker, the big Monarch me and Dad used to have, they have gone in here with a grinder and just dressed this down slightly to provide just enough clearance so that these jaws will clear. And I think that we're going to have to do the same thing, because I'm wanting to get up close enough to face this, but those jaws are very, very close to that carriage right there. You can see that we're clearing there. If I come around here and look, I mean, it's not much. Maybe a 1/16 of an inch. But if we take the carriage in further, like, you know, if I got my facing tool in here, we need to get up closer to this plate, like so. We're even closer. There it is. There's the bump. So you can see our jaws are not going to clear that right there if I get up closer. So close. Now there's other things that we could probably do here to correct that. We probably swing our compound around here and get our tool a little bit closer that way. I'm probably going to check that first and see if I can go ahead and get my tool around here a little bit closer. And if that doesn't look like it's going to work, then I may just go ahead and get my grinder and just dress a little bit of this right here to give us a little bit more clearance. I know that people watching this are probably going to think that's extreme and you should not do that. You're going to damage the machine, whatever. All the reasons why you shouldn't do that. But I'm telling you, this is super common with old lathes. Just about every old lathe that I have ever seen, they have gone in here and done that exact thing, ground that down. And it's not going to mess with the functionality of the machine, the accuracy, or anything like that. Sometimes you just got to do what you got to do. Look how worn this is right here from all the chips slinging and hitting it, things like that. So sometimes you just need to give yourself another 1/4 inch so you can swing on these old lathes. So I did a combo of the two. We've got our compound swung around so that our tool's a little bit closer to the plate. And I did go ahead and I used a 60 grit flap disc and just kind of dressed that edge right there slightly, because it was still wanting to rub even with the compound swung there. So I dressed that down just a little bit. There was a cut that somebody had already put in there with like a cutting wheel. So I just took it to that cut right there, which is about where it needs to go, and just took it down a little bit. Kind of made it look all even there. And if I bring the tool up to the plate now, where we're going to be facing, and you can see where the jaw is going to be kind of meeting at. And now we have some clearance on all 4 of them there. I have not had to do this very often. I mean, this is probably maybe the 3rd or 4th time I've ever had to dress the carriage like that. But you just never know. Sometimes you get a job in there that just brings it right at the max capacity, and you only need a few more thousandths just to get that thing to swing. So I feel good about that now, and you can see Our tool's up there where we can face it, and we're ready to go ahead and proceed. See how it's going to look spinning up. Looking good. All right, so we're going to start with a spot drill, and then we'll go in with a 31/64 jobber drill and then a 1/2" reamer. I just want a nice clean hole that I can indicate on. Let's go ahead and make our first face cut. I got it set at 203 RPM, 20-inch diameter plate there. That's going to put us just over 1,000 surface feet per minute. So that should work pretty good for the insert that I got set up there. Let's just take like a 15 thou cut and a 10,000 feed rate. Hopefully that'll get us a good chip there. Thousandths, set at 0 in case we need to back it off, and let's go for it. Looking pretty good. And of course, we're going to lose our surface finish the further we go in on that. But hopefully we're going to have a good finish all the way down there. All right, just as I expected, got about to the middle and it's losing its good finish there. Rest of it looks pretty good. Actually, I didn't like the way that finished on that last facing pass, so I'm taking one more 10,000ths cut there. Slowed our feed rate down to 5,000ths per revolution instead of the 10, and that should help that finish there not be so rough. And if I don't like the way it feels in the middle there, we'll just go ahead and relieve that a little bit in the center. Did make a 5,000ths relief there in the center, and then we're just going to go ahead and chamfer this corner here. using the same tool. Just looking until it's cleaned up all the way around. I think that looks pretty good. All right, I'm happy with that finish there. So we'll go ahead and flip it around. I'll put my clamp back on here, and I am going to use this brass shim to keep from marring up the finished surface right there. All right, come on, chuck wrench. Gotta go. I'm just gonna go ahead, I'm wiping the jaws here with my fingers just to be sure that there's no dust, mill scale that got cut off or anything landed on that surface and throw out our face. We want it to be as flat as we can get it. And then take my oily hand and make sure there's no dust on this face here. And here's the problem that we're going to have. I may have to re-clamp this because I don't know if it's going to fit in there with our clamp. It usually does not. Seeing if it'll, no, I won't be able to get the clamp off there. So I actually need to set this down, flip our clamp 180 so that it's sticking out this side, and then we'll go back in there with it. Check our jaws one more time. Let's go in with it. Once again, clamping on that same spot that I did not want to clamp on. That looks better. First thing I'm going to do is just go ahead and bump these against the jaws here. Bump the plate against the jaws. That one hit there. That one looks good. That looks good. It's looking pretty good. And what I'm going to do is come in here later after we finish getting this indicated, and I'm going to just sweep these areas in between the jaws with an indicator and see how far out it is and if we can manipulate it just enough. It's you know, it may be 1 or 2 thousandths, and I'd like to try to get as flat as I can. But now we'll use our center hole there to indicate the center of what we just machined. This time we'll use our Starrett 670B ID indicator attachment here. All right, quite a ways off. Let's see if we can get it there. This one we want to loosen our highs, tighten our lows. We want to push our lows that way. So there's our low. We want to push it that way. Loosen, loosen lightly. You don't want it to fall out. Tighten and tighten. All right, less than 5 thou. The low, that's our low. We want to tighten that one. All right, about 3 thou. You get that close, just do your tightening. Half a thousandths. It's going to be good enough right where it's at. All right, indicated in the center. I'm going to do some inspection on the back side here. Make sure our faced side is going to run parallel. All right, this is where I'm going to check the back of that. I've already swept it a couple times and just bumped it just to kind of speed things up. We were only out about a couple of thou, and it's still got about 1 to 2 thou waviness to it. I'll show you what we're doing. So this is the stair number 671, right angle attachment. This comes with 2 tips. You can do one that's actually parallel with the stem of the indicator, or you can put this one on, which actually makes it a right angle there. So it's really great for getting into areas behind like this. I've used this a lot for flange features on the lathe when you're indicating something kind of thin like this, but maybe it's got a machined area out here that you could easily get to. That's not on the chuck jaws. And you want to true up the back side to make the front side true. This is really handy for things like that. So we're just going to go, we're not really going to worry about putting the indicator to the same place every single time. I'm just going to go in between the jaws here. And if we sweep it, just got to be careful not to come down and bump your indicator. So we've got about 1/1000th of movement right there between the 2 jaws on that one. All right, so what we're going to do is just swing this out of the way. Come back in here again. This just speeds up the process right here. You can mount this on the cross slide here and you have an indicator down here and kind of move everything where it comes right back to the same 0. It's just real finicky. So you can see we've got about 1/1000th movement on that one right there too. So it's actually going 1 thou high back here on that. But that's within 1 thou of what we indicated on the other one. So we'll go to the next 2 and see what it's doing here. Just trying to line up on that 0 as close as we can. Just for reference only, don't have to be. So that's the biggest one right there. I've already bumped it. That's your low. And that's your high right there. So getting about 2/1000ths on that one. So it's actually going high against the jaw right there. I'm really wondering if these 4 jaws are no longer completely true on all 4 faces. Probably not. This is a very old chuck. But I think for what we're doing, this is going to work just fine. Got one more to indicate here. That one again, that's about 2/1000. So you got a little bit of a high spot here because the plate on this jaw is actually pushed that way about 1/1000 from the other 3. So I'm going to say we're within 2/1000 on that back face, which is going to be fine for our fixture there. So we're going to go ahead and move on to the machining now. Going to blue us an area about 8 inches in diameter. That is about what the boss is going to be at. Just want to make us a witness mark on here. We're just going to eyeball it close with the rule and the point of the insert here. It's going to be finished slightly under 8 inches. I just want to get it somewhere close so that when we're facing we can come up and stop. Just put us a line on here. Now we can get in here and actually measure it. So about 8 1/8 right there. So that gives us room just a little bit over 8 1/8. So we can bring our face tool in and just stop it there, set a 0, and then we can come back and actually turn this to our diameter that we want it to be. All right, we're ready to start facing. We're gonna make this a total of 150 thousandths deep. The thickness of the part that's gonna be sitting on there is just over 200 thousandths. So 3 cuts of 50 thousandths should be good. Whenever we go to machine it, this is gonna be our size, our target size, 7.963. And I want that to be +0 -2 thousandths. And that should give us a few thousandths clearance for the workpiece to drop onto that register. All right, so we're running the same speed. I believe I was running 203. Let's see here. Calculate my surface speed. We wanted about 1,000. So 0.262 times 20 inches times 203 equals 1,063 surface feet per minute. That should be pretty good. I'm all the way at the very back end of my travel, and you guys that watch some of the videos on the Pacemaker work know that the gib wasn't in good shape. It really needs to be rebuilt or re-scraped. And so it's a little tight once you come all the way back here where it doesn't get used very much. Just use a dial indicator here. And I do have my, my dial set to a 0 once we come up to that machine line right there. Uh-oh. Well, I think I know what happened there, and we probably lost our insert. Let me see if I can. There's a couple gears on this Pacemaker that I am learning comes out of gear. So it's not in the best of shape. I'm just gonna see if I can back it out. Wow. It did not break that insert. Can't believe it. Okay. The lathe did not like that gear, that 203. It just doesn't seem like it's wanting to go in very much. That one. So let's try 174, the next one down. I think it's got good engagement. All right. Continuing to learn this machine. I haven't used it a lot. Here we go again. Okay. Watching my dial for the 0 to come up. Right there. And we'll come back and repeat that. Take another 50 thou. That last cut, this flame cut edge, got that insert. Pretty common. It's always best if you can turn this off and try to get this done in one pass right there. And when you're coming into it like I'm doing, it's not good on those inserts, and that's typically gonna wear it or break it. So before I index this, I'm gonna go ahead and cheat, just try to clean that up with that broken insert. And what I'm gonna do is come back in. I'm gonna go just a little past my depth that I wanna take there. So that's a total of 75. I'm just gonna see if I can clean that up. Just clean it up round, and then I'll index the insert. Let's slow it down just a little bit. Just gonna clean it up. See them sparks? That's an indicator that the insert is bad. Come on. Once it is worn, it does not want to cut. I think I got it pretty well cleaned up. Yeah, so now we can index that and have a clean OD there to plunge into. All right, we got our insert index. I slowed the feed rate down. I'm just gonna make this in 2 passes to hopefully make a nice clean face there. We've got it faced to the depth I want. Now I'm going to go ahead and work on the diameter here. I may end up making a light face cut just to clean everything up once I have this diameter, but I just want to see where I'm at right now. So it looks like 8.2. All right, and then we're going to take it down to 7.963. We're just going to go like we're turning. Coming into my 0 on the dial indicator here. Take a measurement and see where it's at now. Should have about 100 thousandths to come off, I believe. Yeah, 8 inches, 40 thousandths. So we got about 80, a little less than 80 thousandths. We'll take another 50 thou depth of cut here, and then we'll start our finishing passes. All right, and then from here, I'll use my vernier calipers to measure it a little more precise. All right, so we're gonna take our verniers here, and you can see this is what I'm talking about. This is why I'll probably go ahead and face it one more time, just to clean it up. Having these little small edges like this, what I call a register, is can be a little tricky to measure. But a vernier caliper is perfect for that. Getting just a slight touch there. So 7.991. 7.991. I'm just double checking that. Yep, 7.991, and we're going to 963. I think I can do that in 2 cuts. Let's take 20 thou right now, measure it, and then take our final cut. There's 10, 20. Get another measurement on it. All right, 9, 50, 60, 70, 70, 970, so 7.970. So we have 5, 6, 7, 8, 7 thousandths to come off of that. All right, we've gone in 7 thousandths. Let's take a cut. I'm not going to back the tool off on the retract because I want to be on the same spot in case I need to make another pass right there. That feels good. You got that slight touch when you rock that jaw there. All right, so I'm looking for, there's a 50, 60, 1, 2, 62. All right, 7.962 is what I landed on. Here's my notepad. 963 was our target, minus 2 thousandths, so I landed within the target that I was looking for there. I'll grab the sample and it should fit on there. There it is. That is a very good fit on that right there. Perfect. Now, as long as I can get all my pieces machined to that same size there, we're going to be golden. That looks pretty good. That looks good there. You can see we're going to have, you know, good support on the workpiece almost all the way out to the outside there. That's assuming that it's going to stay flat once it's clamped down there. That should work pretty good. So all I got left is a couple of little finishing touches on this. I want to break the corners. I'm probably going to go ahead and clean that face up. Just take like 5 thou across that just to clamp that fuzz where we just turned it. Break this corner off here, and I think we're going to be ready to get it out of the lathe at that point. All right, we got our lathe work completed. We got a chamfer on that edge and that edge. I did a little 5 thou back face right there just to clean that up, where the tool and the chips were kind of rubbing there. Our hole pattern is going to be out past that there, so we're not going to be drilling down through that little 5 thou recess. But that looks pretty good. We're ready to go ahead and transfer this guy over to our magnetic vices and go ahead and get our hole pattern machined in there now. Okay, we've got our plate sitting on our magnetic vices. Now we're going to go ahead and find the center of the hole there, touch off on our surface here for our Z, and then we'll machine the 6-hole pattern there, which is going to be drilled and tapped 7/16. And then we have 4 mounting holes out here that we're going to drill and counter bore, and we'll use 1/2-inch socket head bolts to bolt this directly down there to the rail. We have the coaxial indicator in the spindle here. We'll use that to find the middle. Wrong way. thousandths. Let's see if I can get that out. That's within a half a thousandth. That's good enough right there. So we're going to XY00. We'll run through a real quick simulation of our round fixture here of what we're going to be machining in the CNC mill. To start off with, we're going to use a 9/16 carbide drill to drill our 4 through holes. That's our 9/16 drill. That'd be a solid carbide, and then we're going to use a 1/2 inch carbide end mill to counter bore for the socket head bolts to fit in. So 3/4 inches, 1/2 inch deep. All right, spot drill the 6 holes because we're going to be using a jobber drill here. This is a letter U jobber drill, 0.368 diameter. Chamfer all holes. And then the last stop is going to be the 7/16 tap. And that's it. Let's go run it. So I just made my dry cut on the fixture there, and it's proven to be helpful to do this every single time I get ready to run a new program on something, because I'm always finding there's at least 1, 2, maybe 3 little minor things that I missed in programming that I need to adjust. And that's usually something like the retract height or the coolant, whether I want it disabled or I want flood or through tool. I usually miss that in there. So I had to adjust that for our end mill. And then the tap, I had forgot that I wanted to actually send the tap about 1/4 inch negative Z at the bottom of the hole. So I made those minor adjustments, made the little run again. It's taken about 9 minutes to run through this. It'll probably take just a little bit longer because of the video. In between each tool change, I like to stop it, clear the screen on the video camera there, and then keep going so you guys can kind of see what's happening. So I think we're ready to run. Everything looked good besides those minor tweaks, and I've made those adjustments. So let's go ahead and make some chips now. Holes did go all the way through there, and they did. Okay, we're good. right, let's take a look. Everything looks like it should. So it took about 10 minutes to run through the whole cycle there. Yeah, everything looks great. I'll grab a bolt. I do not have a thread gauge here. I forgot to bring one from the home shop on that, but I do have our bolts that we're going to use, just standard hardware bolts, and we'll grab a socket head bolt and check these and make sure that's going to work too. All right, there's one of our new 7/16 bolts. Looks like it's fitting just like it's supposed to. It's probably going to stop there all the way at the bottom. I didn't anticipate having to run the bolt all the way through there, and it probably would have needed, I don't know, about another 100 thousandths maybe to go all the way through to for if I wanted the bolt to go all the way through, but I don't think it's necessary. So there's our cap head bolt that we're going to use, socket head bolt, and it looks like it's fitting in there fine. I can feel with my fingers that we're a little bit shy of the face, so that is good to go right there. Bottom of the hole. All right, last thing to do, I'm going to go ahead and finish cleaning this off. Let's put our sample up here and we'll show how we're going to use that with our clamp ring in the center to hold it for our final machining. All right, so this is how this is going to work. Now this will be clamped down to the table. I just haven't moved it yet, but our sample here is going to demonstrate. So this one would be, the part's going to be coming off this fixture. We're going to clamp it down right there. Our whole pattern is matching up. And then we have this clamping ring that I call. I've still got to face one side of this off. I'm going to do that next and just do that off camera. But this is going to drop down into the center just like that. And all those holes will align. And then we'll be able to take our bolts like this. Now let me we're just going to go ahead and make sure they all fit. There we go. Perfect. So we'll face that ring off so that we got a nice flat face meeting up with our machine face on our aluminum. And then once this is bolted in here, now we're going to come in here. This is going to be our last operation to machine this bevel, because I wanted to do this with the CNC mills. We'll come in here with, I'm going to use my 1-inch tongue force rec insert mill, and we're going to mill this, we're going to rough it and get it milled down very close, and then we'll come back with a 1/2-inch ball mill, 3-flute ball mill for aluminum, and then we'll try to put a really nice finish on this to finish it out. So that's what the plan is. And as I said before, if I just can't seem to get this figured out on a good finish, then we can take this fixture here and go back to the Pacemaker, chuck it up just like it is here, and use our compound to machine that on there. This is really ideally a lathe job, but my CNC lathe won't do it. The Pacemaker will, so we can use that as a backup, but I really want to CNC machine this. So that's it. Our fixtures are now finished up. Besides getting it down here on the table, this one's already bolted down. I've already located the center and Z. So next step, we're going to go ahead and start taking our raw pieces of aluminum and put them in here. We're going to do this first, get all 8 of them done on this fixture here, and then we'll set them over here on this and focus on getting them all finished. So that's what will be coming up next.